Having looked at the formulas for finding derivatives of various forms of equation, we now want to look at derivative of a polynomial. We need to understand a polynomial as an expression of many terms which take the form a0 x raised to the power n plus a1 x raised to the power n minus 1 plus a2 x raised to the power n minus 2 plus up to the last term a raised to the power n, where a0, a1, a2 up to an are constants. N is also a constant. The gradient function of a polynomial is usually obtained by differentiating term by term of the polynomial. Each term is differentiated independently depending on the form it has taken. For example, find the gradient functions of the following. First, we have y is equal to 4x cubed minus 3x squared plus 2x plus 1. So that is an example of a polynomial. So we find dy over dx. We differentiate each term in turn. So the differentiation of the first term is 3 multiplied by 4, the power reduces by 1. The differentiation of the second term is 2 multiplied by 3, the power reduces by 1. And the derivative of the third function, we have a silent 1. 1 multiplied by 2, the power reduces by 1. And the derivative of a constant is 0. This simplified gives us dy over dx is equal to 12x squared minus 6x plus 2 as the derivative function of the function y is equal to 4x cubed minus 3x squared plus 2x plus 1. We do the same for the second example. In this case, the second variable is not x. The second variable is t. So we differentiate y dy with respect to t, which gives us 12 t squared minus 2 1 over 6 t 2 minus 1 plus 7 t raised to 1 minus 1, and the derivative of the constant is equal to 0. So that is minus 0. And this simplifies to give us dy over dt is equal to 12t squared minus a third t plus 7. Because t raised to the power 0 is equal to 1. So that expression is equal to 1. We can look at more examples of cases where we need to find the derivative functions. The expressions can take different forms as illustrated in this example. So for this case, dy over dx is equal to 6 minus a third x raised to power 5 minus 12 1 over 6 x raised to 12 minus 1 plus 0, which gives us minus 2 x raised to power 5 minus 2 x raised to power 11 as our dy over dx. In the second case, we need to first expand the right hand side of the equation, which gives us x minus 3 x squared minus 1. So we have y is equal to x cubed minus x minus 3x squared plus 3. So dy over dx, therefore, will be 3x squared minus 1 minus 6x plus 0. As the derivative function, also written y prime. In the third case, we have y is equal to, instead of the square root sign, we can raise it to power half so that all they are in the same format. X is to a third minus x. From indices, this will be equal to x, opening the brackets, we add the fraction, we add the powers. So this will be a half plus a third, which is equal to 5 over 6 minus x raised to 3 over 2. So dy over dx, therefore, is equal to 5 over 6 x, 5 over 6 minus 1, minus 3 over 2 x, 3 over 2 minus 1. And this gives us the derivative function as equal to 5 over 6 x, negative 1 over 6, minus 3 over 2 x raised to power a half. In the fourth expression, we need to factorize the numerator, which will give us x minus 2 x minus 2 divided by x minus 2. So this is y. X minus 2 cancels out, and we end up with the dy over dx is equal to 1.